Welcome to the third video and third question of the FED 2017 paper, mathematics paper. Okay, let us begin. So we have been given that the equation 3 into 2x minus 10 into 3 to the x plus 1 plus 3 to the 4 equals 0. That is, we should find the values for x that satisfies this equation. So in a competitive exam, sometimes you just simply work from the answers and you substitute. Okay, you take the answers from A, you substitute, you move to B, substitute. You should be very fast. Okay, there are calculators that can even do that. You see the one that the answer that will substitute will give, and you can do it like that. And the other way again is to simply do the mathematics. In this video, we'll do the mathematics. So now let us say, we'll now select it very well. So we're having 3 to the 2x minus 10 into 3 to the x plus 1 is same as 3 to the x multiplied by 3. In indices, this means in indices a to the n plus m is same as a to the n times a to the m. That is, when they have the same base, you just simply add the power. So that is what they did to x plus 3, was indeed 3 to the x times 3 to the 1. So they just simply added the powers. Okay, so that's what they just did. So I'm going to just break it down. The worst thing is when you have addition on powers. Don't accept to have addition on powers when working with this type of problems. So we now get 3 to the 2x minus 10. I can multiply 10 and 3. 10 times 3, then 3 to the x, then plus 3 to the 4 equals 0. And this way I can write it neatly to look as 3 to the x as well. Please like this video there. Just hit the like button. It will not debit you from your mom. I hear people saying that if you like videos, it debit you from your mom account. Please just like the video, please. Thanks for liking. Okay, we got this. Now what I will do is simply I've just multiplied 3 and 10 to give me 30. Okay, then 3 to the x, I've just simply, this is 3 to the x, all that to the 2, that is 3 to the 2x. Okay, so I can just let now 3 to the x equals to y. No, let me let m for Mohamadu. That's my name. So m squared minus 30m. This is simply m, but the power up there, so m to the power 2. I just write it as m squared, obviously. Then 3 to the 4 is simply 81. 3 times 3 times 3 times 3. 3 to the 4 is 3 times 3, 4 times. 3 times 3 is 9, times 3, 27, times 3, 81. So you get 81 equals 0. Voila. So let us go ahead and break it. So I would like to break 81. So 30 is same as negative 27m minus 3m plus 81. So 30 is same as negative 27 minus 3, that is negative 30. Okay, all of this equals 0. And what you do again here, if you take we are now going to factor this. So I can write it very well to look like this: m squared minus 3m minus 27m plus 81 equals 0. And if you arrange it like this and you take the ratio of the terms, the coefficient, so here we are having 1, here we are having negative 3, so 1 on negative 3. If that is equal to the coefficient here, negative 27 on 81, the coefficient here and the constant term, excuse me. So we are getting 1 on negative 3 will give you negative 1/3, and negative 27 is 1, here is 3, you still get negative 1/3. Each time you have this ratio it is equal to, then know that you can factorize by grouping. Okay, each time you have it like this, then you can factorize by grouping. Very interesting. Okay, now how are we going to factor it out? So here we are seeing that m is common, so we'll be having m into, here I'll factor out m into m minus 3. Then we now get the other one, will get 27 is common, so we'll be having minus 27. So I'll have minus 27 into m plus 3. But when you are factorizing with grouping, these terms here have to be the same. Okay, now I will send this negative sign inside. Negative 27 into m minus 3. Okay, sorry, factor it also wrongly, because if you open the bracket you'll be having negative 27m minus 81, not positive 81. So here have to be what? Negative 3. If this is negative 3, then you'll be having negative 27m, negative times negative 3 will be giving you positive 81. And you can see the quadratic formula for equations like this. So you get this one now is common, so I'll go equals 0. I will go ahead and factor out now m minus 3. It is common, so we'll be having m minus 3. What will be left in this bracket is simply m. What will be left in this other bracket is negative 27. other equals to 0. I will now simply, if A times B equals 0, then there are two things. If this is happening, then either A is 0 or B is 0. If none of them is 0, it can't ever occur. So they are telling us that the product of these two terms, this term and this term, equals 0, and then one of the term must be 0. So either m minus 3 is equal to 0 or m minus 27 equals 0. And if you solve this, you simply get m equals to 3. You take the 3 to the other side. And if you solve this, m equals to 27. But are we looking for m? No, we are looking for x. But remember, we said m equals 3 to the x. Okay, so we now get 3 to the x equals to 3. That is m equals to 3 means 3 to the x equals to 3, and m equals to 27, it means 3 to the x equals to 27. And from here, just write this as 3 to the power 1. You have not changed anything. Each time the bases are the same, then the parts must be equal. So we get x equals to 1 in this is okay. And this one also, before we equate, we have to make all of them have the same base. So we get 3 to the x equals to 27 is same as 3 times 3 is 9 times 3 is 27. So indeed, it's how many 3's we have in 1, 2, 3. So you get 3 to the power 3. That is that. And since the bases are the same, we also equate the part. So x equals to 3. So since it was a quadratic, we are just like looking for two values for x, and we got it 1 to be equals to x equals to 1 or 3. So we go to find our values where x equals to 1 or 3. That's are the values that satisfy the equation. Had it been you just substituted, you got your answers, you are there. So that satisfies option 1 and 3. That option D. Sorry, it is not visible. That is option D. Thank you very much for following. If you like the video and you subscribe to the YouTube channel, you can get the question paper on my inbox. No big deal. Thanks you very much.